because they couldn't be here.
Yeah, so I was actually going to say that if you know Jaime, Daniel, or I, then you'll know that I'm not on this paper. Unfortunately, Dan and Jaime couldn't come, and so they asked me to present this work. So the space of this work is whole body gestures with low arm fatigue. So Dan and Jaime and Dan are interested in designing in this area. And the idea behind this is they're looking at gestural interfaces for controlling computers in your environment. And they want to design gestural interfaces that essentially could be used for longer periods of time. So maybe, several minutes at a time or even hours at a time. And if you think about a lot of the gestures that are used with things like the Kinect, those gestures are very effortful. They essentially create fatigue. And so this is sort of in that space, and it's doing some design work within that space to figure out how we can understand better users' perspectives on designing gestures that have low arm fatigue. So as you see from the title, this is in the space of elicitation studies. And we've seen a lot of elicitation studies in the HCI literature over the last several years. I think we all know what's involved. You ask participants to perform a task with a computer, you compute in the environment, and you essentially compute agreement amongst those participants. So really what you're trying to do is you're, excuse me, trying to see whether or not there's some consensus, some sort of cognitive mapping that makes sense for end users in terms of the task that you want those users to accomplish. The problem with elicitation studies is that there are biases that crop up in those elicitation studies. So thinking about the space of whole body gestures, the first bias that Dan and Jaime were looking at in this paper, again, sorry about my voice this morning, it seems a little off, but the first bias that they were looking at in this paper was something called a legacy bias. And the idea behind a legacy bias is that when people have experience with an interaction, that tends to color the type of gestures that they propose. And so thinking about this space, if they've used a Kinect, if they've seen a movie where there's whole body gestures being performed, then that colors the gestures that they actually propose. And so if you think about that, there are some benefits to that in some ways because it actually drives consensus among participants, but there are actually some liabilities associated with that as well. And one of the liabilities associated with that is if you're trying to uncover new interactions or you're trying to modify an interaction in some way, it actually becomes really difficult for you to break that bias for participants. The other bias that they talk about is something called a performance bias in the paper. And the idea behind performance bias is essentially that when you get people to perform a study over a short period of time, they may choose to do something that doesn't make sense if they're actually going to be performing the action over a longer period of time. So in this case, they may create gestures that are larger in scale than you would want if you were going to be performing those gestures for a much longer period of time. And so in order to overcome those biases, what they did is they actually looked at the idea of soft constraints. And the specific soft constraint that they used in this study was the addition of arm weights to participants. And the idea was that that would encourage participants to think a little bit about the scale of the gestures without necessarily preventing them from performing those gestures overall. So you could still perform the gestures without too much problem if you really wanted to, but it would hopefully cue them in to thinking about whether or not that was a good choice of a gesture if you were going to be performing that gesture for longer periods of time. And so in order to test to see whether or not this worked, what they did is they did, essentially another elicitation study. I don't want to go into all the details of the elicitation study. That's in the paper. I think the important thing about the elicitation study is that you've got two conditions, a control condition where there are no weights and a constrained condition where there are weights attached. And with respect to the way that the study was organized, it was arranged in 3 blocks where the first block was always the control condition, and then they had 2 constraint conditions. They organized it that way because in pilot studies they found that when they added constraints, then that soft constraint persisted over the remainder of the study. So it actually biased them in the control condition, and they wanted to understand, essentially how quickly and whether or not soft constraints would immediately cue people in to varying their performance, or to at least considering things like, in this case, arm fatigue. And so they had two constraint blocks just to measure that convergence, that consistency. So they captured data, and they captured video data and Kinect skeleton data from their participants. They coded it. The specific things that they were looking for in coding were the body part used for the gestures, and whether or not the gestures corresponded to legacy gestures. So, whether it was a gesture that was in the Kinect gesture set, or whether it was a gesture that was popularized in, a couple of movies that they looked at, would essentially classify the gesture as a legacy gesture. And so the goal there was to see whether or not they'd broken some of the pre-existing biases by the addition of soft constraints. So just to give you an idea of what their gestures look like, here's a participant performing a gesture, and you can see on the left the control condition, on the right the constraint condition, and you can see that the gesture shrank in size a little bit. Here's a gesture that shrank in size quite a bit more. Here's a gesture that was modified because of the scale of the gesture, so you can see it was quite subtle just with one hand. Here's a participant who started out using their arms, but then switched, you'll notice, to another body part for a gesture subsequently. And lastly, you've got a participant right here who switched to another body part, and the gesture was actually quite subtle. I don't know if you caught it, but it was actually a really subtle foot tap that this gesture used. That was the gesture that was used by this participant to perform the command once the constraints were added to that participant. So looking at their results in terms of body part used and legacy gestures, what they found is they found that for body part used, there was a statistically significant drive away from using the arms, given the fact that they'd added these soft constraints, and that the convergence was basically immediate. There was no difference between the first constraint condition and the second constraint condition. That's replicated as well by the legacy gestures. So you see that there's a bias toward legacy gestures in the control condition, which is, at least reduced in subsequent conditions, and it stabilizes very quickly. Sort of stepping back and thinking about the overall goals of this paper, what they were really trying to accomplish was to create gestures that were that consumed less effort, that were easier to perform. And so if you look here at the consumed effort scores, you see that that's been reduced quite a bit. Consumed effort is a quantifiable metric of arm fatigue that exists in the literature. Last thing I'll call out just before concluding, I'll just point that there's a really nice discussion section in this paper. I read the paper a couple of days ago, and I had a chance to take a look at the discussion section, and I think it's a really nice discussion section that talks a lot about the potential biases that may be added by soft constraints, and talks a little bit about more generalized soft constraints. So I thought that that was really a nice part of the paper, and I'll point that out for you. With that, just in conclusion, soft constraints seem to work in terms of increasing diversity and in terms of lowering arm fatigue. And with that, I'll provide you with my answers to any questions, and if you want answers from Dan and Jaime, you can also contact them, I guess. So, thanks.
Hi, I'm Paul. Thank you for the presentation. When I see the examples there, they are quite exaggerated to me. So, like, why did you choose to constrain them instead of trying to collect the natural gestures, by using some tools like Wizard of Wiz system, something like that? Do you know Wizard of Wiz system?
Sorry, I didn't catch the system that you said.
Yeah, Wizard of Oz system is like something in NLP field. We also develop some.
What's that? Wizard of Oz. Oh,
yeah,
okay.
Sorry.
Sorry, got it.
Yeah.
Okay.
Yeah, so
Wizard of Oz.
by using that kind of tool,